Eleanor Williams's claims that she'd been trafficked by an Asian grooming gang led to protests, racist attacks, and claims of a cover-up. Eventually, she was jailed for lying.
I don't want to be that girl that cries rape. I'm not that person.
I'm Sky News' Jason Farrell, and in Unreliable Witness, we ask, why did she lie? And explore unanswered questions with new revelations. Follow Unreliable Witness wherever you get your podcasts.
Hello, this is Tom Cheshire on the Sky News Daily, standing in for Neil Patterson. It's set to pass in an arc over North America on Monday.
I've got Pink Floyd's Dark Side of the Moon timed so that the last line of Eclipse goes off just as Bailey's beads are coming up and we go into totality.
It's a total eclipse of the sun. Very rarely do millions of people get to see the sky go dark in the middle of the day. And many of them are understandably very excited. From enthusiastic amateurs,
we've been told it's well worth the effort, and it's like one of those once-in-a-lifetime sort of experiences. We're even planning on doing a little bit of eclipse chasing so that we can find a region without clouds so we can view the event.
to academics.
We're going to see all kinds of neat things, a lot of solar flares, maybe even a coronal mass ejection at some point. Those things are important to us because those solar flares actually affect life here on Earth.
Eclipses have fascinated humans for millennia. There are even cave paintings way back when, and they show the swirls of the corona, the wispy ring of the sun's atmosphere that's all you can see in the darkness during an eclipse. They've helped scientists discover new elements, investigate how our atmosphere works, and even proved Einstein's theory of relativity. Later, we'll hear from Pam Melroy, NASA Deputy Administrator and former astronaut, about exactly what scientists are hoping to learn from this eclipse. But right now, I'm joined in the studio by Thomas Moore, our science and medical correspondent. Let's start with the eclipse itself, just in terms of why we're excited, because it's rare, right? Well, it's not rare, but it is rare. Two different ways of thinking about it. This happens quite a lot, but not in a way that's useful for us.
Yeah, what we're talking now is about a total solar eclipse. Partial eclipses are quite common, but a total eclipse, about any one point on Earth, you stand a chance of one in every 375 years. So unless you're prepared to travel, you're really unlikely to see one even in your lifetime. This one, though, is going to be sweeping across much of the North American continent. So there's 31 million people living underneath its path, and that's why a lot of people are excited. A lot of people are travelling there too. It's almost impossible to get a hotel room now within the moon's shadow.
Yeah, I think I saw a map which is going around the internet. You can see Airbnb bookings, and it exactly matches that path that is going to take it across.
There you go, surge pricing.
I remember when I saw an eclipse, maybe we'll talk about it in a bit, but you feel this really strong sort of almost pagan energy, and it goes back to, olden times, like millennia ago, people feel that way. Now we know a lot more what they are, how they work. Can you just explain what exactly happens with the total solar eclipse?
Well, it is just super weird, isn't it? I mean, if you think out long before we understood the movements of the sun, the planets, the moon, and so on, there was no understanding of why suddenly daylight would turn to night in the middle of the day. And you can understand why people would be alarmed because suddenly something has eaten the sun. Many cultures, that's how they explained it. But now, of course, we understand much better that it is the perfect alignment of the Earth, the moon, and the sun, with the moon coming between the Earth and the sun. And that only happens once every 18 months or so, because normally the moon is tilted, its orbit is tilted compared to the way the Earth goes around the sun. Of course, 70% of the Earth is ocean, so that the moon's shadow is in the middle of nowhere. Nobody ever sees it.
Of course, we're not going to be in that shadow in the UK, so bad luck us. So it's going to be in the US, you mentioned. How long are we talking? Is this hours? Is this minutes?
So the eclipse will start over the Pacific Ocean. It'll take quite a while before it crosses over the Mexico border. And then the shadow races at something like 1,500 miles an hour northeast, crosses over into Texas, then sweeps up through the Midwest states, and then Vermont, and then into Canada, and out into the Atlantic over Newfoundland. So there's Canada, Mexico, 13 US states will get a really good view. So there's a lot of people. But as you say, sadly, the total eclipse will be over by the time it reaches the UK.
And it doesn't last a huge, 2 to 4 minutes.
It's really quick. Yeah, absolutely. For totality. And a lot of people will see a partial eclipse, but you need to be so close to that central shadow for you really to get any impression of what it is like, because the sun is so bright. So even if the moon covers 90% of the sun's disk, all you'll think is, oh, the sun's gone behind a cloud. It really needs to be beyond 99% covered before you think, this is weird.
So in terms of what you actually see, don't look at the sun, obviously, that's the advice, but what can you actually make out?
That is a really important point, because people can really damage the retina by looking directly at the sun, even when it's partially covered. So about 15 minutes before totality, you really know that it's coming now, because the light fades really quickly. With seconds to go, you get what's called Bailey's beads. That's where the remaining glimmers of very bright light are shining through the valleys on the very edge of the moon. And then as the moon completely covers the sun's disk, you get a flash of light. It's called a diamond ring, that last burst coming through one valley. And then there's totality. And then the whole process is reversed as the moon goes across.
Just in terms of the crowd, the sort of people who come and do this, people who chase these eclipses and do it.
Yeah, the shadow chasers, for sure. It's a big thing because, of course, it's so rare at any one point in anyone's lifetime that you really have to make the effort to go and see it. And that is what is happening in the US too. And I think a lot of people are going to make the mistake of trying to capture this event on their phones. You won't remember it. Experience it, feel it, see it. You will be able to see the pictures later on Sky News, on NASA TV. There are others who can do that really important work. Just live it.
Oh, absolutely. I tried to film an eclipse for Sky out on a plane over towards Iceland, and it's some of the worst footage ever recorded. But the experience was absolutely incredible. There is nothing like it. But Thomas Moore, thank you very much. In a minute, a former NASA astronaut and actual space shuttle pilot will be with us to explain why scientists like her are so excited about this eclipse. Along with the estimated 31.6 million people who will see the total solar eclipse on Monday, scientists from around the world are heading to the US to use the event for research. NASA is sending up planes to capture images of the solar corona, and it's launching rockets to study how the drop in sunlight during an eclipse affects Earth's atmosphere. Pam Melroy is Deputy Administrator at NASA. She's the second highest ranking official at the space agency, and she's a retired astronaut who piloted missions in the early 2000s in the space shuttle.
It was, every pilot's dream, I think, to fly the space shuttle, an extraordinary vehicle. Yeah, docking to the space station was really fun.
Pam, thank you so much for joining us. Have you seen a total solar eclipse before yourself?
I have not. I've seen several partial, but I'm very excited because the totality is quite different. People talk about this very mysterious effect with going into total darkness. Animals start to behave differently. It's a very mysterious feeling.
I've actually been in the totality once. This is the only time I'll get one up over an astronaut, but I have been in the totality, and mysterious is absolutely the word for it. But we do know a lot more about eclipses now in terms of how they work, and they also teach us a lot. And that's something that NASA and other organizations are going to be looking at when this eclipse happens.
That's right. We can learn so much, and it's a cosmic coincidence that the sun is 400 times larger than the moon and 400 times more distant. And so there is no other planet in our solar system that has this perfect alignment where the moon is the same size as the sun. So it's quite remarkable that we get the opportunity. So we get to learn things about the Earth, we get to learn things about the sun, and we can learn things about the moon. We can do exact laser ranging for the distance of the moon, but we, of course, most importantly, are learning about the sun's corona. It's a very mysterious place. It's millions of degrees hotter than the sun, which seems very strange. And so we have competing theories about that. And we'll be close to solar maximum. So we're going to see all kinds of neat things, I really hope. A lot of solar flares and hopefully maybe even a coronal mass ejection at some point. And those things are important to us because those solar flares actually affect life here on Earth by affecting the satellites and the communications networks. And of course, you might also get a beautiful northern or southern lights out of it as well. And then here on Earth, those affect the ionosphere. That's the ionized or charged part of our atmosphere that's right at the edge of space. That's very important to us because radio signals are bounced through that part of our atmosphere. So we're going to be studying all of these things.
I suppose it's, the glare of the sun is so bright the rest of the time we can't see it. It's like when you're driving down a motorway and, someone's got their lights up and you're dazzled by it. So this is a moment we've been waiting for when it's just a bit quieter, I suppose, and we can really look at those things. Is that how it works?
That is how it works. We do have coronagraphs that can block out the light of the sun, but they are imperfect because of the shape of the sun. It's not quite a perfect circle. So we have to kind of make it a little bigger. And so that means that we can only see parts of the corona. The moon is just perfect, and it's got these little ridges that allow us to see deep into the corona. It's called by the scientists the universe's perfect coronagraph. And we get to see things that we cannot do even with our best instruments.
That's very convenient and helpful from the moon to do that for us. Are there instances in the past where we've used other eclipses to understand the universe better or understand things on Earth better?
Oh, absolutely. In fact, very famously, a solar eclipse was used to prove Einstein's theory of relativity. So the idea behind relativity is that gravity can actually affect light, that mass and light is connected. So what happened during a total solar eclipse, we were able to see the starlight because the real brightness, as you pointed out, of the sun was blocked. We could see the starlight as it appeared to get very close to the sun. Of course, it's millions of miles away, but the gravity of the sun bent that starlight and as a result proved the theory of relativity.
And I love the idea that, you have that theory that Einstein's come up with, and then everyone's thinking, oh, well, actually, in the next solar eclipse, we could put this to the test. In the same way, again, that kind of stretching back millennia idea, people were predicting them, would look forward to, and we're doing the same sort of thing. I think there was a Chinese emperor who beheaded 2 people for not predicting the eclipse. That doesn't happen at NASA, I'm sure.
No beheading in our science directorate.
It would be a firm but fair approach. I don't know. When it comes to today, though, you mentioned the solar flares. So we live in a very sort of networked world and even more satellites in space than last time there was a solar eclipse. Is this about sort of resilience and understanding? Like, if there were to be a solar flare, a big one could disrupt a lot of communications. And that's not just people WhatsApping each other. That's bank machines working. That's GPS working, which controls all sorts of financial transactions. There's a really serious risk there, right?
Absolutely. And I think some of the experiments that we're doing specifically that look at that transmission and how sunlight, but also how solar flares might disrupt it, we need models and better prediction in order to do that. And of course, we worry about our astronauts in space. With solar flares, we're protected in low Earth orbit and on the surface from some of the worst radiation from those solar flares. But as we go out into the solar system, back to the moon with our Artemis campaign, send humans beyond out to Mars and other destinations, we need to learn how to predict that solar weather and that deadly radiation much better.
The fact that it's got that really long arc over North America, how useful is that in terms of the science of it?
Well, it's an extraordinary opportunity. I mean, I'm thrilled at the idea that millions of people will all be looking up at the sky together, wearing glasses. Always got to wear your glasses. But what that means is we're really tapping into citizen science. We have over 40 projects that are around the eclipse, and we have tons of projects where people can either come together and get trained to participate in a scientific experiment, or you can use your cell phone. And we're looking at things like the shape of the sun, and we want to take a lot of pictures from a lot of different perspectives. It's going right over such a heavily populated part of the United States. This is really an opportunity for millions of people to get involved. And we're really excited that out there, future students who may study STEM have the opportunity to both participate in science, but also feel that wonderful awe at the universe that is what inspires certainly us at NASA.
And just sort of wider than that, I mean, you mentioned the Artemis mission, the idea of going back to the moon, going to Mars after that. How exciting a time is it for explorers in space?
It's amazing. We're creating with our international partners, including the UK, what we consider to be a blueprint for responsible exploration throughout the solar system. It's very focused on the science. And astronauts are all engineers and scientists and are very passionate about the work that we do in space. As we go out, we can explore, understand from the moon more about the history of the environment that the Earth has been in. When we go to Mars, we can study why a planet that used to have running water and a thick atmosphere is now cold, dry, and barren. Like to figure that out to make sure it doesn't happen to the Earth. And we have so much to learn about our place in the solar system. So it is a very exciting time. And I'm proud to say that we're doing it with our international partners because we need representatives of humanity as we go out and leave the cradle of Earth.
You mentioned responsible exploration there. Is there the danger that it becomes irresponsible? And is that tied to the idea of a new space race with countries like China, that actually getting somewhere first or extracting resources perhaps from somewhere like the moon or asteroids, that might become a priority rather than what you describe as responsible exploration?
That is exactly what we're worried about. We really want to set the right precedent. I think it's important to understand that how we explore is just as important as what we find. And to do that, we're really working with like-minded partners. We even have a plan, it's called the Artemis Accords, to talk about transparent and responsible exploration that we're politically committed to say we're going to do this the right way and we're going to consult and we're going to not interfere with others and we're going to be responsible.
And just lastly, Monday, I know you're going to be very busy with it, with all sorts of official duties. As you mentioned, there's a huge amount going on, but what's your plan to see it? Will you get a moment to just enjoy that mystery?
I really think so. I think one of the things I'm excited about is we'll have nearly 4 minutes of totality. I'll be in Indianapolis, and, that's amazing. We'll really get a chance to feel it and experience it. That's one of the very cool things about this eclipse as well, is totality is very long lasting. And I will most definitely take the time to soak up that experience. I'm super excited about it.
Well, Pam, enjoy it hugely. Thanks very much for talking to us.
Thank you, Tom. It was great.
That is it for today. And while you sadly won't be able to see this total eclipse from the UK, you'll have to wait until 2090 for that. You don't have to miss out either. You can watch it happen in real time between 7 and 10 p.m. here on Monday on Sky News. That is Total Eclipse Live on Sky News.